dug out some information on the production of Lake Superior science by doing a web of science analysis that I think will interest you. We're going to talk a little bit about what in the lake is changing and why, themes that have already been addressed by previous speakers. I want to say something about our track record of anticipating change, which isn't very good, but I'll illustrate that a little bit. And then at the end, talk a little bit more about not just setting CSMI priorities, but setting priorities for the whole Great Lakes science operation. Much, much bigger than any of us in this room or any of the institutions we represent. So let's do it. So the lake-person interaction, I'm an ecologist, so I put species on the paper and then I draw arrows between them. But this is a lake and a human population. And we have our anthropogenic impacts that have been addressed already this morning. We'll keep talking about them. We've talked less about this return flow, which today we refer to as ecosystem services, the things about the lake that affect people. And we're eventually going to get to the blue-green algae bloom in this topic. But for my colleagues in the room, and I know some of you out there, you don't have a lot of attention span for this particular slice of scholarship. But I do want to point out that this is where public support comes from. So even if you don't really give a hoot about the people, they're the ones who are paying the bills. So we should pay attention to that. This is a small slice of a project that is soon to be published. It's in revision at the journal called Ecosystem Sciences, where a number of colleagues down here and I tallied the ecosystem services of the 21 largest lakes of Earth. And there are only a small number of things that can be quantified and the information is reliable and such. But so we have information on like how many people are out there, the fisheries harvest, how much marine freight there is, recreation and tourism, water use of different kinds, and electricity generated. And these are the figures just for Lake Superior. And we have all 21 lakes in the publication. But this here is the rank of Lake Superior on that list of lakes for each of these things. So this is a snapshot of how people benefit from Lake Superior compared to other large lakes of Earth. And the thing where Lake Superior stands out is marine freight. You may know this, but you'll probably see ships moving back and forth through these 2 days. There is more tonnage of freight transported on Lake Superior than any other Laurentian Great Lake and any other Great Lake of Earth. Lake Superior also ranks high in power generation, not so high in fisheries, kind of middle of the pack there. And recreation and tourism, one estimate that I didn't do, but I only read, was $246 billion per year. Can be attributed to Lake Superior and recreation and tourism. That's only on the U.S. side. The study only considered the U.S. To talk about that across all 21 lakes where we don't have economic analyses for all 21 lakes, we used social media data. So we used Flickr photo uploads, like have been used in a number of other studies in the past. But Lake Superior ranks 4 there. So marine freight, number 1. Recreation and tourism also really, really important compared to even other large lakes of Earth. Those numbers only scratch the surface because how is Lake Superior valuable to people? Oh my goodness. That is mostly about our emotional connections and the way it shapes our views of who we are and in fact why we're even here in the first place. And I've had folks from the tourism industry talk to me and again and again, from different people, I hear surveys of tourists will report the number 1 reason they visit Duluth is Lake Superior. So that's why the lake's important. Why does that matter? That attraction that people have to this resource is very psychological. It's based on its reputation as an unusual, clean place. That's what we're working against here. That's how we make Lake Superior valuable to people, it's its reputation, more than anything else we can measure with a meter or a yardstick or anything else. And that's why this business of social science of attachments to place, I think, is, we just need to do a much, much better job of understanding that in order to really embrace this whole lake and people interaction. Okay, so second part of the talk, producing science. And the way I addressed this was to dig into the web of science. And, you know, this is, I love this pyramid. You know, we generate data from that. Some of it is useful information that gets distilled into knowledge as we think about it and talk about it, interpret it, and then ultimately we're aiming for wisdom. But sort of what's the base of the pyramid like for Lake Superior? And one measure of that, and I think it's not a bad measure, is publications. So what I want to do now is show you some things I've discovered about the publications in the scientific literature on the topic of Lake Superior. 2,700 almost papers have been published since 1900 on the topic of Lake Superior. 1,800 of those from the US, 650 from Canada. The journal Great Lakes Research is the most frequently, is the highest represented journal in this database with 15% of the papers. After that is ES&T, CJFAS, and some others. The first thing, I sort of expected an increasing trend with time, but I found this interesting. So this is years, you can probably see it. Yeah, 1960 to the present. I don't really know what happened around 1990. I didn't have time to really dig into it too much, but there's this like multiple fold increase in the generation of papers on Lake Superior about that time. And it's been increasing since. This is what you get for inviting a university professor to give this talk. These are the institutions publishing about Lake Superior. Go Badger, or go Gophers, go Bulldogs, we're number 1. Badgers number 2. Here's the USGS, Michigan Tech, EPA, Michigan State, University of Michigan, Fish and Wildlife, Environment Canada, NOAA. What I want to point out is the conversation so far this morning has, and I understand it, has been very management related. That's what you're here for. It's a marvelous process you're undertaking here to coordinate. A point I'll come back to at the very end, though, is how do we bring the whole research community together to talk about what science priorities are? And I will argue we don't do that at all, because we don't have a forum for academics and tribal representatives and agency folks and everything to have conversations like you're having now about agency work on one lake. This data may or may not be reliable because only 30% of those 2,600 papers are included here. But this is who's funding the work. These are the funders who get acknowledged in papers on Lake Superior. And I was shocked when I saw this. And again, it's only 30% of the papers, but NSF is the number 1. I expected that to be important, and I've had NSF program officers stand in front of me and say, well, doesn't EPA fund most of Great Lakes science? And I didn't really have an answer to that. Today I do. I just tried out this graph. No, actually, NSF is vitally important to producing Lake Superior science. Here's NSERC, Sea Grant, EPA, etc. And some of you are in the room. Congratulations. These are the most prolific authors. Everybody's getting their binoculars out. The open bars are authors who publish on the Lake Superior region from a geologic perspective, so they don't really count. Those of you working on fish, you are amazingly prolific. And a couple of other top authors are basically working on toxins. Steve Eisenreich, when's the last time he's been on Lake Superior? It's been like 20 years or something, and he's still number 2. So If we're going to understand the future of Lake Superior science, we should know something about what we're standing on as a foundation, and this is it. And I'll come back to this again. The whole research community is building this knowledge that we all rely on and that ultimately the public depends upon. Okay, what's changing? What could go wrong? We've seen this already. I don't disagree. Lake Superior is in reasonably good shape. It's, from a 30,000 foot view, we might say it's not changing much in most respects. I don't disagree. The number of stressors in Lake Superior, of course, is much lower than the number of stressors in especially the lower Great Lakes. We all know all this. Here's the Lake Superior LAMPS table. Status is basically good, a couple of fares. And so maybe everything's fine and we don't need to pay much attention to it. But we do know things are changing, and that's what I want to focus on. This is a representative plot of some of the stuff I've been involved in with many colleagues. The nitrate has been doing really interesting things for 100 years, changing over time. It's not a human health concern as best we understand, but it is a key dynamic element of the nitrogen cycle, and it is changing. I could get into serious trouble if I say very much at all about fish, because I don't know. But the fish, of course, are changing. They always change, but there's this peak and drop off in the pelagic prey fish. Recent paper by Burney et al., anthropogenic climate change has altered primary productivity in Lake Superior. And Ewan, sitting over there, published climate warming and changes in cyclotella. And so things are, the lake isn't truly static, we know that, but things are changing. Is it changing in a way we need to worry about? And that's where I get to climate, which has already been mentioned in previous speakers, and I was interested and actually somewhat heartened to see that it was the #1 identified priority by the Mail survey. I'm sure you're all aware of this. This is change in ice cover duration, change in summer surface water temperature in the Great Lakes, and the big red bullseye here is indicating that especially the offshore eastern basin is warming very quickly. There's limnology behind that. It should be the part of the lake that warms fastest. I don't really have time to go into too much about that. But it is also, the place in the Great Lakes that's warming the most in the sense of peak summer surface temperature. This is from the O'Reilly et al. Paper, many authors, including some Great Lakes folks. Red means the lake is warming. Many lakes around Earth are warming. This is the eastern and central moorings of Lake Superior on a frequency distribution of warming rates. Again, pointing out that Lake Superior is among the world's most rapidly warming lakes. Why? I do have just a little time for some basic limnology here. This is why Lake Superior can do that. It's all about seasonal stratification. Maybe not all, mostly about seasonal stratification. We come out of the winter and the lake gradually warms, essentially the whole water column warms slowly until it hits 4 degrees. And then the lake stratifies, and now the warmth is concentrated in the surface layer as it warms faster, warms more. And so in a warm year, coming out of a low ice winter, we hit 4 degrees relatively early in the year, mid-June, and the lake warms. In a cold year, we hit that 4 degree mark much later, almost 2 months later. And so the lake has much less time to warm coming out of a cold winter than out of a warm winter. And that 2-month head start means the lake can warm the surface layer can hit a peak temperature much higher in a warm year, as in red, than in the blue year. What will the next CSMI year be? Probably warm, because we have more warm than cold years anymore. But you may encounter this Lake Superior, or you may encounter that Lake Superior, and I would argue those are really different places. Projections of future climate change, again, I'm sure everyone's aware of this, but let's just put it out there. Projections for average temperature in our region. We project even more future warming. We project heavy precipitation to be more and more a factor. For these reasons, I think Lake Superior is a crucial test bed for science. Lake Superior may offer us the best place on Earth to study a pure, quote-unquote, climate signal. Because the other anthropogenic influences are smaller, but climate is big. And so the kind of argument I have to make when I go to Washington and ask for money is, well, why do this study here? It is because it's very likely to be the best place on Earth to teach us what simple climate warming by itself does. Let's talk about the blue-green blooms, which is now occupying a lot of our attention in my lab. Out of nowhere, in 2012 it turns out, we started experiencing nearshore algal blooms. So far, there are 2 years that we call major blooms, 2012 and 2018. 2018 was the biggest of all. And in a few other years, there have been smaller blooms, basically observations at one beach on one day. So we have 12 and 18 major blooms, some minor blooms, and also some years when there have been no observed blooms at all. This has gotten the public's attention. This is the species that is involved, Dolichospermum lemmermanii, and that also is Lake Superior. And thank you, Brenda, for being there with your camera that day. I don't know where we would be today without your photos and many other things you provide. This is satellite photography from August 9 of last year, the day we, Brenda and my lab, became aware of a bloom occurring. The satellite imagery only has good information in this little part of the lake on this particular day. We'll zoom up here, and there is Lake Superior during this 2018 algal bloom, and there's the bloom running along the shoreline, no more than a half a kilometer offshore. You know, it might have been somewhat green out here, who knows, but the real thick blue-green soup was a very nearshore phenomenon, lasted a weekish, plus or minus. So what a monitoring challenge that is. It is no surprise that we lack a good monitoring data set that tells us about these blooms. I mean, it's practically just, you know, the surf zone almost that's involved here, somewhat further offshore. But it's a huge lake. We don't have every possible point in space sampled. And when the blooms are that small and they last about a week, what's the chance of us recording these things with traditional monitoring approaches? Not real good. We are now doing a lot more monitoring targeted at this zone. We have sensors out there now, but we didn't have much out there before. Here is a bunch of folks enjoying bathing in cyano bloom on Lake Superior during that event. So it was small in space, short in time, but this is where all the people are. And I like to know what's going on in their minds. How much is this event changing the way these people think about this resource? To me, that's the most sort of scary proposition of all this. Toxins that have been measured have been low or undetectable. Study continues. There's a few more results that we're working on through Todd Miller at UW-Milwaukee. But we don't have a scary toxin story to tell. Here's a study that just came out about Lake Erie, Canada side. Uncontrolled algal blooms on Lake Erie could cost Canada $5 billion over 30 years, with the largest of those costs being to tourism and to non-users, the so-called existence value. Again, what's going on in people's minds when they think about this. That's the big economic cost. So that brings us back to social science and sense of place. And I want to pause for a minute and have all of us internalize this message, which is, this is not what restoration looks like. Vast amounts of money, tremendous amount of effort, has done a lot of great stuff with GLRI. Activities around the lake are targeted at restoration, doing a lot of great work, but this certainly isn't restoration. Back to climate change. So now we have all the years for which we have relevant surface temperature data obtained through the buoys that J. Austin at LLO has maintained since 2011. And so from those buoys, which are on this side of the lake, but they're at the western arm, this is the temperature of the surface water of Lake Superior on July 1, with the years ranked from warmest to coldest. This is the peak temperature that was reached each of those years at some point, and the date of those temperature peaks. And then the years for which we have bloom observations, we have the maximum temperature observed over a few day span around that time of the bloom. So blooms on the South Shore are observed when the surface temperature ranges between 19 and 23 degrees. Most years, you could argue all years, because 19.8 is a little higher than 19.6, but most years reach that temperature. So it's not that the lake has warmed to a somehow temperature cutoff or something. The lake gets to that blue-green soup temperature essentially every year. But there are some patterns. The coldest 3 years are the 3 years when there is no recorded bloom. 3 years, oops, I have to, little caveat, 2015 is a little special, I'll talk about it in a second. But other than 2015, the 3 years with no blooms were the coldest years. The other years, most of them were warm. 2015 was the warmest year, but it's weird. It warmed really fast, really early, and then the temperature plummeted. So it shows up as a warm year in our analysis, but it's weird. Otherwise, we have warm years producing blooms. And this point I already made. All years reach the temperatures where blooms are observed. But here's the other point. There isn't much difference. If we're getting blooms in the low 20s, principally, and these are cold years, it looks to me, from this limited amount of data, like the lake was really close to the temperature where we promote blue-green blooms, and it's just kicked over that edge some years now. That's the impression I get from admittedly a little bit of data. This is more detailed, and I think really makes the temperature case better than anything. This is temperature recorded at LLO2, which is located there. The blooms are here, and by June 1 or so, the temperature here is pretty dang similar to the near shore. There's a little bit of difference earlier in the year. 2012 and 2018 were the years of the big blooms. And so there they are. 2011, 13, and 14 are 3 of the years, maybe 3 of the 4, or depending on how we classify 2015, the non-bloom years. Very, very clear difference there. And getting out my crystal ball, what about this year? We're going to see a bloom this year? The first little bit of data, I'm like, oh, great, it's a cold year. We won't have to worry about blooms, and it'll help test this hypothesis that temperature is involved, because we'll have another cold year. Then weather happened, and it got really warm here for a while. And here's now 2019, as of last Friday, running up there in that range where we do see blooms. So this is in no way a formal ecological forecast, but on this information alone, I will not at all be surprised to see some kind of a bloom this year. Somebody's mentioned storms, and I've mentioned storms. So those 2 years of huge blooms, 12 and 18, perhaps coincidentally, perhaps not, were the years of the greatest single rainstorm events in that period of time. So here's the probability density of rainfall in the watershed on the South Shore, and there's the June 18 and June 12 rainstorms, and these were like 500-year floods. That's basically all we've got, is we got this coincidence between huge storm and big bloom. It would be sensible to think that the storms are bringing in propagules, as Kate's working on, or sediment in different ways. The storms could be mechanistically connected, but there's a lot of science dots to connect. Okay, so I gotta hurry up. Lessons from the bloom so far. The lake's not immune from change, we knew that. This is not what should be happening if we're truly restoring the Great Lakes. We didn't see these coming. Gaps in our monitoring, gaps in our knowledge, evidence mounting that climate change is a driver, and predictions are hard. Let's talk a little bit more about priority setting. And so I looked to see, what are the mechanisms that we use to set priorities for research in the Great Lakes. And I'm very responsive to what's happening at the National Science Foundation. They don't specifically do yet, I hope they will, but they don't specifically do Great Lakes planning. They did do oceanography planning, and so here's 8 priority science questions out of NSF for the oceans, and the ones in red are lake relevant. So we can take something from this. This was an activity that I helped with, published in L&O in 2017. Mostly academics in the room for that one, trying to establish what were the grand challenge questions. So I refer you to this paper in Oceanography 2017. This is a word cloud from the participants in that workshop. Change, climate, water, predictions were the most frequent words mentioned. Here's what's going on now, and I want to be sure you're aware of this, but also make a plea. So I am aware of at least 3 actions for Great Lakes science planning. One comes to last year's fiscal federal budget, where the USGS was directed by the House Environment Committee, I don't have that exactly right, to host a collaborative forum, identify resources needed for a Great Lakes integrated science plan, and I understand the USGS is working on that and gathering some information for this. We heard about the IJC. This is not really a formal statement, but I have contacts who are on the Science Advisory Board, and they told me it was fine to tell you that there's a lot of discussion going on in the SAB of the IJC about developing a science plan by themselves or in cooperation with others. I'm real excited about that. I think that's a perfect place for something like this to happen. And then I also noticed, just by reading the GLR action plan, that there's some talk about science priorities there. So, in closing, let's pause to ask what we want our legacies to be. And I want to also talk about data here for people looking back, people in the future looking back to now. What are they most going to want to know? I argue they're going to most want to know what the state of the system is. And I draw inspiration from one of my science heroes, Margaret Davis, retired faculty member from the University of Minnesota, who once said to me, early plant ecologists were so busy arguing about whether there was a climax community, nobody bothered to write down what the plants were. And there are books and books and books written about succession in plant communities, and there's no data about the plants. And we're certainly not that way today, but if you try to access data on the Great Lakes today, it's nightmarish. We have to do better for ourselves and for future generations. Expanded monitoring, better archiving, and improved data access. Or else, why are we doing it? So that's it. Here are my take-homes. The lake's changing. There's significant degradation. We're not good at predicting the future. That is a system failure of science. It's not a personal failure by us. It's the system we're working in isn't yet enabling accurate predictions. We have to think more about prioritizing, and let's not forget to write down the state of the system for the